So, hello friends, we are back again with the day 17. We are doing 50 days challenge of physics, and in that, we are doing today's topic, which we are doing today is force on a charged particle in magnetic field. As we know, the force on a charged particle is given by the formula F is equal to BQV sine theta, and F is equal to Q into V cross B. V cross B, देखिए, when we talk about V cross B, we use this right hand thumb rule. We'll start from V and then we'll move on to B, and this thumb will give us the direction of the force. So it is the cross product. But for that, we have a simpler rule, which is the Fleming's left hand rule. Fleming's left hand rule. The Fleming's left hand rule is this one: force, magnetic field, and then current. Force, magnetic field, and then current. FBI. The most important thing is FBI. F for force, B for magnetic field, and I for current. And here we'll be talking about current uh, because we haven't given the current in this equation, so we'll be using this as the velocity. So velocity has been given to us, so we'll be taking it as velocity. This is, say, our thumb. This will be considered as the force. This is the first finger, the forefinger, index finger. So this will be considered as the magnetic field, and the middle finger will be considered as the velocity in this case. Now, how to understand this thing? For that, we'll be moving on the next part. But before that, I'll tell you, since it is a charged particle which is entering into a magnetic field, so charged particle is already having a force which is due to the electrostatic force. So F is equal to QE. This we have done in electrostatic. So that force is already there. So what if we have both the forces joining together and they are applying the effect continuously? So that force is called Lorentz force. Lorentz force. FL I'll be saying, and it is equal to what? Electrostatic force plus the magnetic force. So it is QE plus BQV sine theta. Very important. I'll just give you one more important thing here. If we take Q common and we write it into the vector form, then it is E plus V cross B. This is the force in vector form. Now, very important, if in any situation this Fe becomes equal to Fb, Fe becomes equal to Fb, then Fe is Qe and Fb is BQV sine theta. You can leave this sine theta because if angle is 90°, this will become the perpendicular one. Then sine theta, sine 90 is the maximum one. So Q and Q will be cancelled and we'll get the value of V, which is E by B. This is also the case in electromagnetic waves also, where the speed becomes C, speed of light, E by B. So we have another formula also where we can compare electric field as well as magnetic field. I'll give you one more comparison later on in the next video. Now let's move on to the most important thing here is about how these forces are going to be happening in this thing. What we are going to discuss here is that how the forces are there, how F is equal to BQV sine theta change the whole situation. Let's see this situation which is in front of you right now. So what is it saying? It's saying particle is entering from this. Let's talk about this thing. The particle is entering from this is a charged particle Q, which is coming with some velocity in this direction. Clear? Or maybe it is coming from any other direction. Let's talk about this direction. Let's say the velocity is entering from this direction. This is V. Clear? So what we have to apply? We have to apply this left hand rule. See my video also. Magnetic field is inward. Cross, I tell you yesterday also, cross means inward. So this is the index finger. It is moving inward. Then velocity. This is velocity. This is right now going in opposite direction. So we have to twist our wrist. Remember, wrist को move करना है. Will not move anything else. So you can see how things are happening. This is magnetic field. This is velocity. Uh, yeah, this is magnetic field FBI. This is magnetic field. This is velocity. the force will be taking it into the inward. The force is taking into the inward. I'll just zoom it out a little bit. Yeah, see this thing. This is the velocity. Magnetic field is entering inside. Magnetic field is inside, then the velocity will be in different direction. See, one more thing which we have to remember is here the charge which is given to us is minus q charge. And remember, current is opposite to the negative charges. Opposite. Current is opposite to the negative charges. I'll give you one more thing. I'll again talk about the lowest point. This point which we are discussing, let this is point A. Magnetic field inward. This is the velocity which is going in that direction. Yeah. And the force which is thumb, right now it is going inward. Sorry, right now it is going downward. Here it is going towards the center. So why it is so? Because what we have taken I in wrong direction. I will be opposite to this one. This will be considered as I. I'll explain again. If the electrons are moving in this direction, then current will be moving in opposite direction. So current is in opposite direction. So you will see the change. See, it is in opposite direction now, and now the force is moving inward. So this is taking it towards this point. Say the velocity reaches to this point, the particle reaches to another point. Remember, again, we have to see the direction of positive charge. If the charge becomes negative, means direction will be opposite to that charge particle, because ultimately our rule is father, mother, and child. FBI. Father for force, mother for magnetic field, and child for current. So now at this point, at point B, I should say, I'm writing it here. Point B, the magnetic field is inward, velocity is opposite, but velocity has to be converted into current. So it will be coming again in the downward direction, and the force is coming in upward direction. So you can see the force is going inward. Similarly, when it reaches to this point, the force will be inward, this will be inward. So ultimately, what will happen? It will form a circular motion. It will be going into the circular form. And whenever any body is moving in circular form, we have a force that comes into play, which is called the centripetal force. And this centripetal force will be balanced by BQV. So let's compare. mv square by r is equal to bqv. V will be cancelled. We'll get the value of b, bqr by m. Very, very important thing which is here is magnetic field is constant, charge by mass is constant. So velocity depends on resistance. Velocity depends on, sorry, I beg your pardon. Velocity depends on radius. So if you increase the radius is this much, velocity is small. Radius is bigger, velocity is bigger. That is the most important point. And let's talk about the time period. Time period is distance. It is 2 circumference. Since it is a circular motion, divide by the velocity. Velocity just now we had calculated. So T is equal to 2 pi r divide by BQR into M. R and R will be cancelled. So time is 2 pi M by BQ. Another very important point. Time remains constant. Whatever the velocity is there, whatever the radius is there. And since time is constant, so frequency, which is 1 by t, it is also constant. This frequency is called cyclotron frequency. Cyclotron, I know it is not in our syllabus, but my dear students, my dear friends, frequency we have to do, because there are some questions in our syllabus where it will be given a proton and an alpha particles are moving into the magnetic field. What will be ratio in their radius? What will be the ratio in their time period? So you have to go by this formula only. Last but not the least, which I want to discuss, if it is in 3D, if it is in 3D, what we'll be doing? So let's see if it is in 3D. So what we are going to do? We are going to see that how they are moving in 3D. So that forms this kind of shape, which is called helical shape. So if a MCQ comes, when a charged particle is placed in a magnetic field, what will be its shape? you will be answering helical, not circular, because circular is there in 2D. If we talk about 3D, 3D we have this helical shape. Already all the expression has been discussed by me, so I'll be not discussing so much. That's it for today. See you tomorrow with another video. Thank you so much. God bless you all.